Hi, my name is Harold Watkins. In this video, I'm going to walk through a Windows desktop application I built called FDRS Log Quick Triage, which is designed to quickly analyze and filter large diagnostic log files. Before I get into the application itself, I want to give some background on why I built it. I worked across the automotive diagnostics and cybersecurity space with companies such as Ford Motor Company, Tesla, Opus IVS, Autel, ProTech Automotive Solutions, as well as running my own company, LR Automotive Diagnostics and Programming. Across those roles, I spent years working with vehicle diagnostics, ECU communication, ADAS systems, network tooling, and security and diagnostic log data. One consistent problem I kept running into was that logs are large, noisy, and time sensitive. Yet engineers still need to quickly identify what matters, reduce noise, and justify decision using real evidence. This application is my attempt to solve that problem by building a tool that extracts signals from noise and supports real engineering decision making. In automotive infrastructure and cybersecurity environments, diagnostic logs can contain thousands of lines. Important failures, access issues, or system faults are often buried deep in the file, and manual review is slow and error prone. This tool is designed to speed up that initial triage while preserving data integrity. Although this application is built around automotive diagnostic infrastructure, specifically diagnostics and repair system log files, the underlying approach is intentionally broadly applicable. The same log triage and signal extraction workflow applies anywhere where large volumes of system data must be monitored, filtered, and acted on quickly. This includes cybersecurity and SOC operations, cloud and enterprise infrastructure, industrial control systems, telecommunication networks, and regulated IT environments. At its core, the project demonstrates a reusable engineering pattern for extracting actionable signals from noisy data-heavy systems without modifying the original data. Built in C Sharp on a .NET framework, the application loads a diagnostic log, extracts high value entries, classifies severity, allows real time filtering, and exports exactly what the user sees for documentation or escalation. I'm going to demonstrate. So this is the application. I'm just going to walk through each function, starting with the open log. The workflow starts with the open log button, which uses standard .NET file dialogues to load the log and process it line by line. I'm just going to demonstrate that here. This is the log file. Once uploaded, then we can begin to filter through. The next text box is the search, and we're just gonna type in security, and as we type it in, we see that it begins to filter. The search box uses event-driven programming in C Sharp to filter results instantly as the user types without reloading the file, which you see here. I'm going to erase this. The next box is the severity dropdown, which you see info, warning, error. All right, just to demonstrate. The severity dropdown filter results by info, warning, or error, which are classified automatically by the application. Then the next box is the unique only. The unique only option collapses duplicate messages so repeated errors don't overwhelm the the view. So you can see right now it's a lot to go through, but once I click on unique only, it filters, removes duplicates. As for the result grid, this is what you're seeing. This is what you're seeing, the result grid. The result grid is a read-only .NET data grid view displaying line number, severity, and meshes to preserve log integrity. And the final button is the export CSV button, which you see here, which would download to your local system, which I did already. I'm gonna open it up here for you guys and girls. There you go. Here we go, right here. Thought I lost it, which you see here. So the export feature saves exactly what's visible on the screen, honoring all active filters. Now I'm gonna go into a deep dive on some of the script that I feel is important. Just move this. The first script is render pipeline. Uh, just gonna grab this and filter for it. Let me close this. Uh, all users' interactions funnel into a single render method called apply filter, which you see here. This keeps the UI consistent and prevents state related bugs. You may say, what is a state related bug? A state related bug happens when the screen doesn't match what the app thinks is happening. In other words, different parts of the app disagree about what the current state is. For example, imagine this sequence. One, you load a log. Two, you filter by error. Three, you type a search term. Four, you uncheck unique only. If the grid shows results from step two, but the export uses results from step three, that's a state bug. The app is in two different states at once. In this corrects um, make sure that doesn't happen, which is called which is a single render pipeline. The next deep dive I want to do is deal with immutable master data set. Let me filter for that. This is here. The extracted log data is treated as immutable. It filters only affects what's displayed, not the underlying data, which prevents accidental data corruption. For example, when I load a file, the original extracted entries are stored once and never changed. If I search change severity or turn on the unique filter, I'm only changing what's shown on the screen. The original log data stays untouched, so there's no risk of accidental deleting or corrupting the original log. The next deep dive it deals with severity classification. Grab that. Severity classification in this tool is done using simple explainable rules. Instead of using a black box model or hidden logic, each log message is evaluated against a clear set of keywords. If a message contains terms like error, fail, NRC, or denied, it's classified as error. If it contains terms like warning, timeout, or voltage, it's classified as warning. Anything else defaults to info. This approach makes the behavior easy to audit, easy to justify, and easy to tune as real diagnostic data is involved, which is critical to cybersecurity and safety related environments. In the last deep dive I want to do deals with hash sets. Well, deals with duplications and reducing noise, which is supported by hash set. One problem engineers run into when reviewing logs is alert fatigue. The same error can appear dozens or hundreds of times, which makes it harder to see what's actually different or new. To solve that, I added a duplication option using a hash set. When the unique only option is enabled, every message is checked against this set. If we already seen the same message before, even if the letter casing is different, it gets skipped. The result is that repeated noise is collapsed and the user can focus on distinct failure modes instead of scrolling through duplicate alerts. These design choices support faster decision making, reduce cognitive load, and defensive outputs. The same patterns apply across automotive systems, SOC alert triage, and incident response tooling. Overall, this project demonstrates how a C# and .NET based GUI application can turn raw log data into actionable insight using clear, maintainable engineering practices. Thank you for watching.